Welcome to Learn Software Architecture channel. If you are a software architect who is willing to extend his architectural skills, or senior software engineer who wants to become a software architect and follow this path, or junior or mid developer who is interested in architectural topics, there is no better place to learn software architecture than here on this channel. Last week, I talked about evolutionary architecture, and this started series of episodes on this topic. There, I described to you how to understand software architecture, what are the chapters and steps of evolution inside your application. What is important, this evolutionary architecture approach is so easy to implement that you can easily take it into your applications. Today, we are going to focus on the first step of evolution. And this first step of evolution is focusing on simplicity. In the beginning of each project, we have a lot of decisions that we have to make. However, we have a really limited knowledge about our business domain. That's why quite often the decisions that we make in the beginning of the project are inaccurate, and then we need to change it. How to deal with that from perspective of evolutionary architecture is that in the beginning of the project, we should shift as many decisions which are on infrastructure, which are on solution architecture and so on. We need to shift it in time. That's very important because when we don't do that, we will fall into traps related to different components. And here we can talk about things like event streaming, microservices, cache, NoSQL databases, and so on, which we are putting into our project in the beginning, and then we need to live with all these decisions that we made, and it might be really complex within time. Additionally, the entry threshold for our colleagues who are entering the project is really high. So why not to make all these decisions or most of these decisions when we gather enough knowledge about our business? And it's not only about the business logic inside the processes that we are modeling, but it's as well about the behaviors of our users, the number of changes in modules, processes, and so on. And based on that, we can make in future way better decision than in the beginning. The other thing that we are doing to ourselves in our projects is that in the beginning, we are projecting infrastructure for way bigger traffic than we will face in the next weeks and months. So we always think that our application will be used by millions of users every day, and it will generate enormous number of requests. However, in most applications, we won't be needing such a scale. We will be serving some intranet applications used by our internal users, or we will build a product that will be used by companies where 1,000, 2,000, 10,000 people will use it on a regular basis, but that's it. So of course we might have applications that will require such a traffic that I mentioned before, but it's a minority of these applications. So let's look into the example infrastructure calculation that I prepared for you. And you can see that if we have 100,000 daily active users who are sending 100 requests per day each, it will give us 10 million requests a day. And then if we take into consideration that one day we'll have around 16 hours on average of the usage of our application, because we will operate, for example, in Europe in business hours, plus additionally we might have after business hours, but for sure it won't be 24 hours. And then we have 10 million requests that we are dividing into 16 hours, which will give us 625,000 requests per hour. And if we have such amount of requests per hour, then per minute it will be around 10,500 requests, and then it will be around 170 requests per second. So now my question is it a high number? Some of you might say yes, it's a lot, but in general 173 requests per second is not that much. Of course, it will require some tweak inside the architecture, but still it's not a scale of Google, Twitter, or any other big application. And this is something that I showed you for 100,000 daily active users. You can imagine that probably in the beginning your application won't operate on it. And your application can grow with your users, can extend with some components that will help you to fit your needs. And this is very important. We need to fit our needs for the current state of application. You don't plan to do something that maybe will occur in 1 year. No, here we are focusing on something that will occur today or will occur tomorrow. And based on your observation that you will do with your monitoring solution, with your fitness functions and all the stuff which you have there, will allow you to just grab and add component when you really need it, when it will solve your problem. That's a great approach to building applications, because every time you add your component, most of your team understands why you added it, because of some reason, a reason of high traffic, slow reads in a database, slow writes to the database, and so on. So this is something worth to remember. When talking about evolutionary architecture or any software development, software architecture related topic, it's always great to base on some business case. That's why I prepared for you Fitness Studio case. Imagine that we are building Fitness Studio application. This Fitness Studio application will be at first sold to several companies, several fitness studio, which in total have around 500 up to 1,000 users who are attending to different trainings, coaching sessions, and other stuff like that. We collected several fitness studios and we discussed with them about the business processes that they are struggling with, the needs for the application, like calendars, scheduling trainers, sessions, and so on. And based on that, we divided our business domain, Fitness Studio, to several different smaller parts called subdomains. Then we set up boundaries around it. And then in the end, we created out of it several different areas which are called on our site modules. I don't jump into the details of how this business analysis was handled, because it's not about that topic. If you are interested, I invite you to go to Evolutionary Architecture repository and check this out there. What are the areas that we extracted from our business domain? These are areas of passes where we are registering new pass when customer signs the contract. Then we have offers where we are preparing new offer when our pass expires. We have, of course, contracts where we are preparing contract and signing the contract with the customer, and some kind of a reports block. This is, for simplicity reason, today a separate module. When you will be thinking about that in future, it might make sense to create a report per each module, or it might make sense to approach it from completely different side with some external tools and so on. And as mentioned before, when our customer signs the contract, then the pass is registered in passes module. When it is expired, then we are sending the information that this pass got expired to our module of offers. And based on that, our offers module will prepare a completely new offer to our existing customer. Additionally, in contracts, preparation of a contract and signing the contract, and generating of the passes that were registered in last month in reports module. The most common problem while building new application is that you need to select correct deployment strategy. If you want to go with single deployment unit, like with monolith, modular monolith, or with multiple deployments units like microservices. And I would like to tell you that for a majority of cases, you won't need microservices from scratch. And that's good, because you don't need to focus on all these problems like network latency, network failures, deployment scripts, and so on, how to combine all these things that they work well together, how to test these microservices, and so on. Usually when we are diving deep for the first time in microservices, we want to do that because it's something fantastic. We read about it, we saw a lot of materials in the internet about it, and we just want to do the same. We just want to follow this world. But after the first time, when you build your application and when you see all these problems, then you will always think first, if I really need microservices for my next application, because you are hit by all these problems that I just mentioned. And that's why in the beginning of your application, in majority of cases, it makes real sense to just follow the monolithic approach. And if I can suggest something, is to follow the modular monolith from the beginning. The next thing is infrastructure. While thinking about infrastructure, we are looking into different solutions that are possible, and often we fall into the trap of saying, yeah, we are just going with Kubernetes and then we will see how it goes because it gives us so much power around our infrastructure. And that's true, Kubernetes is a powerful tool. This is something that will help you to run your application, but to be honest, for the beginning, it is just an overkill in most of the cases. If you are not working in an existing infrastructure, for example, in your large-scale organization where you can just plug into your Kubernetes clusters, then it makes no sense to introduce it for most of the applications. Instead, think about the easiest possible solution to handle your app. And you might even think, okay, I can put my app both database and web application on one server. And that's fine, you can do that. Probably it will work, for sure it will work. The question, what would happen if you require more resources on SQL server, or you require more resources on your web app server? Then it will be something where they will be fighting for these resources. So usually it makes more sense to just split it in the beginning into two separate instances. So you have instance for your SQL and you have instance for your web app. Now, what next? How can I decide what should I choose? Here it's up to you. You can go for virtual machine, you can go for your hosted servers, you can go for some services like app services in Azure. You can even think about some kind of simplified solution for orchestrating all these containers like Azure Container Apps or so. These are things which already complicate your area of thinking. So at some point it will be your decision if you want to complicate things or you just want to go as simple as possible and then observe what is going on at separate blocks, at separate components, and decide on your needs which you have at the current moment. So at some point you might face the situation where your two blocks are not enough because you need to optimize the reads inside your database. Here you will then split this database into master and replicas, where each replica will be responsible for reads and master will be responsible mainly for writes. Here you will be able to optimize your reads that will go to multiple different replicas. Or at some point it might be worth to think about cache because too many replicas will be there and it will be way easier if you introduce the component of cache. Or maybe you will need to optimize writes with sharding of the database, where each database will be responsible for storing each set of data. For example, based on your customer IDs, that IDs from 1 to 100 will be stored in one database, 101 till 200 in another one, and so on and so on. Of course, this concept is way more difficult. I might describe it in one of the videos that are unrelated to this evolutionary architecture. You might ask now, okay, man, you told a lot of theory here, but how you can transform what you just talked about into the code? And this is something that might be a little bit tricky to you because you might not accept what I will just say. Instead of having multiple different project solutions for your application, we are based here on one project which is a production code, and one project that is a testing project. How can I integrate it in my application? We are building so great application and so on. I heard it multiple times, and I will tell you that if you are a startup and you are building your MVP, you don't want to focus on no and low code solutions. You should always aim to provide this MVP in 3 to 4 weeks. That's the rule of thumb, general rule of thumb. And if you have just one solution project for a production code, which is then responsible for all your business processes, it's way easier to focus just on features that you need to deliver in this 3 to 4 weeks. Afterwards, if it is successful, if your product goes up in a market, then you can think about migrating it to another step 2 of evolutionary architecture that focus on maintainability. But coming back to the topic which we are discussing today, when you have such a test project and when you have this production code project, you might ask, okay, we will have a mess, we will have a big ball of mud because we are putting everything into monolith. But what if I tell you that you can already modularize your application from the beginning, even with such simple code structure? How you can divide it is to base on namespaces or packages. It depends how it is called in your language that you are programming in. But in general, it's just about the division. You don't need to divide all your modules into separate projects. You can just start dividing it by folder, package, or namespace. That's it. You just need to make sure that these folders, namespaces, packages do not communicate directly between each other. So the communication here can be done, for example, based on events. This way, you are not creating tightly coupled system, you are creating loosely coupled system. At some point when you see that, okay, your code grew to some size that is not anymore maintainable, then you can just grab one of these modules and extract it to the set of the projects. And you can grab another module, extract it to set of projects. And here, by set of projects, I might mean something like you have only API and data access projects, or you might have something where you have API infrastructure, application, and core layers as a set of projects for your module, and so on. Because you need to remember one important thing. You don't set a universal architecture for all the modules. You are selecting it based on your needs. And now we are coming back to the project paradox that I described in the beginning of this video, where you need to decide so many different things in the beginning. So how you can decide on the architectural structure of your solution in the beginning of your project, where you don't know how much changes would it be there in this module, or how many people will work on that module, or how many people will use this module in production, and so on. Based on that, you can then evolve to a different structure of your projects, but in the beginning, it might make sense to just grab them all and separate them by folders, put there all the functionality, and just deal with it. One more thing here that I would like to mention about this evolutionary architecture first step, which focuses on simplicity, is that from the beginning, I advise you to just grab and go with vertical slices. Vertical slices represents the processes that you have here. So you can imagine that till today, you are organizing code into technicalities like handlers, queries, endpoints, and so on and so on. And then inside you had all the endpoints, all the handlers, all the queries, and so on. Instead, it might make sense to just grab the process like sign contract and put all the code related to signing the contract into the folder which is called sign contract. Then you have a vertical slice, a process, entire process in one place. Same goes for all other processes. Then your solution is structured in a way that you have a folder per process, folder per sign contract, prepare offer, mark passes expired, generate passes, and so on. So this is the way how you can structure it. If you are interested on how it is done in practice, I invite you to just visit our evolutionary architecture repository, where we are showing step by step how to evolve from this chapter, which is focused on simplicity, till the chapter which is focused on complexity. There are 4 different chapters. You can observe the change of the code. How did it migrate from one to the other? What is important is here that we are focusing on this module split, on the vertical slices, and so on from the beginning. So from chapter 1, you can see it, how it is done within folders, namespaces, and we presented how to do it with .NET and C#. Let me know what you think about such approach. Would you agree on something like that in your project, or would you immediately split it into several different projects? Do you always want to introduce components, or you are thinking about these components based on your needs? When you need it, you add it. Let me know in the comments. Thank you very much, and hear you in the next week when we will be talking about chapter 2 of evolutionary architecture that is focused on maintainability. Thanks a lot and have a good day, guys.